All right, we're still talking about the geometric distribution, and this time we're going to look at how to do all of those things that I told you that you would need to be able to do for each of these distributions. I know that you don't like notation, but part of what I want you to get out of this course is to see the notation and realize that it's not really something scary. When we did the standard deviation, I have a feeling that after you did the process, you found that it really wasn't that bad, not nearly as bad as you thought it was going to be when you first saw the formula. So here's some notation. When we're talking about our probability distributions, P by itself is the probability of success as opposed to P of X. So lowercase p, that's the probability of success. Q represents the probability of failure, and this is on each trial, right? So each time you flip a coin, the probability of heads, or each time you roll a die, the probability of 6, or each time you try to shoot a free throw in basketball, maybe your probability of success is about a 0.3. Q on each trial is the probability of failure, which is always just 1 minus p, right? So if p is 1 in 6, then Q is 1 minus that, which would be 5 in 6, like we did when we looked at dice last time. For purposes of the geometric distribution, X is the number of trials it took to get a first success. So if we said flipping the coin, we did tail, tail, head, then X in that case would be 3. It's just the letter we assign to represent how many trials is it going to take to get our first success. And here's our ugly formulas. The probability that our first success will be on any particular trial is just the failure to x minus 1 power times the probability of success. Okay, so the probability of failure to the x minus 1 times the probability of success. And if you think back, we already did that when we talked about rolling the dice. Suppose we did not get a 6, we did not get a 6, and then we did get a 6. Well, the probability of not getting a 6 is 5 over 6. The probability of not getting a 6 the second time, still 5 over 6. And then the probability of success. So if your first success is on the third roll, then you have 2 failures before that. So it's Q times P. It's as easy as that. The notation's a little bit ugly, but it just means probability of failure up into when you get the success. Don't need that there. So I said those things that we were going to have to calculate were probability of getting our success on a particular trial, our first success on a particular trial. Also talked about finding the mean and the standard deviation. And these are real easy here. The mean is just 1 over p. So in the case of the coin, where the probability of success is 0.5, 1 over that would be 2. In the case of the dice, where the probability of success was 1 in 6, then the mean would just be 6. The standard deviation is just the square root of the mean times 1 less than the mean. So if the mean is 6, this is going to be the square root of 6 times 5. Real easy. And we'll look at an example in just a second here. And then the range of likely outcomes is always the mean minus 2 standard deviations to the mean plus 2 standard deviations. I put that there as a courtesy. I may not do that in the future because it's always the same formula. You should already know it. So, quick example here, just to work these out, and then we'll do the next video completely of examples to get you used to doing this. Suppose you're trying to shoot a can on a fence post, just like they do in those Western movies. Trying to shoot the can off the top of the fence post, and the probability on any given shot that you will accomplish this is about 1 in 5. That's about how good a shot you are. Somebody may be better shot, somebody may be worse, but for our purposes, your probability on each shot is 1 in 5. Remember, it has to be constant in order for this to work. So, P is 1 in 5. We're given that. I'm going to use a decimal approximation here, 0.2. Q is the probability that you'll miss. Well, that's going to be 4 out of 5, or 1 minus 0.2, which is 0.8. Okay, so P and Q are real easy to calculate. Now, what is the probability that we hit the can? Right, I'm sorry, I didn't talk about why this is a geometric distribution. Right, if you're trying to shoot a can off the fence post, you're going to have repeated trials until you get a success, at which point you're going to stop because the can's not on the fence post anymore. So what's the probability it'll be our third shot that knocks the can off the fence post? Well, that's real easy. That means we're going to have two trials first. So that's going to be 0.2 to the second power, right? Just the probability of failure to one less than the successful trial. And then we're going to multiply that times oh, my bad. The probability of failure is 0.8. So 0.8 to the second power times 0.2. 0.8 to the second power, because that's the probability of failure, times the probability of success. And I worked this out before. That gives us 0.128. Meaning there's about a 12 or 13% chance that we're going to hit that can with our third shot. Or if we were to do this over and over and over again, about 13% of the time we would hit the can with our third shot. What's the probability we'll hit the can with the eighth shot? Well, that's going to be 7 misses first, so 0.8 probability of failure to the seventh power times 0.2, and that actually is going to be about 0.042, about a third. About 4% of the time we're going to hit it with our eighth shot. Now let's find our range of likely outcomes. When are we likely to hit this can? Mu is just going to be 1 over p. Okay, mu is 1 over p. 1 over 1/5 will be 5. So that's our average. Sigma is going to be the square root of 5 times 1 less than 5, which is 4. That's the square root of 20, which is about 4.47. Right, if we double this and subtract it from 5, we're actually going to get a negative number. So call that 0. If we double that, we get about 8. Add it to 5, we get 13 point something, which we will round inward to 13. We always round with the range of likely outcomes, we always round in. So our range of likely outcomes is 0 to 13. Remember what that means? 95% of the time, we should be able to hit that can with no more than 13 shots. Now I'm going to stop this here because we're a little long, and I'm going to include the calculator shortcuts you see here in the next one. See you then.